So one of the common misconception is that is the following. Here, what we are talking about is the distribution of the answer we produce by the Monte Carlo method, right? No, assuming that we know the true probability, right? So all of these analyses are assuming we have the true probability, and now we have a distribution of the possible answers we get. In practice, do we ever know the true probability? No, we never know the true probability, right? So how do we produce this interval of 99 or 95%? Yeah, if you take the mean of all the samples, you actually just get one sample out of the distribution, right? I mean, this is the distribution of the mean of all your samples.
Take the mean of those, you can estimate what the actual P is.
Also, what you're suggesting is I can repeat the procedure for many times, then I can have a better estimate of what the mean is. But then it's the same, except for your distribution has shrinked by another factor, right? So if you repeat the procedure for 100 times, you are shrinking the width by what? By square root of 100, which is a factor of 10, right? So that doesn't really solve the problem in principle. In principle, whenever you see a confidence interval, the confidence interval reported by somebody who uses a Monte Carlo method is actually just a sample of a random interval. Okay, it just has 95 or 99% of chance of actually including the true probability. So when I actually perform the procedure, I may actually get a P sample that is here, for example. And now, if I use the same width as, let's say, if I use a 2 sigma width, then I have the width of the green. The confidence interval that that person reports is actually a 2 sigma width around that sample, right? The tricky thing is that if I use the same width of the window, I'm just shifting the window, and if this sample lies within the 95% interval of this Gaussian distribution, then this random sample that person reports also includes the true probability. Right? Does that make sense? So the confidence interval is actually it's the theoretical analysis and the practical reported value has different meaning. The theoretical analysis assumes I have the true value, and I'm producing a confidence interval where the randomly sampled, randomly computed result actually lies within the sample. And then when you see somebody report a confidence interval, that confidence interval is actually a random interval. It just have a 99 or 95% of probability of including the unknown true value. It's the same for estimating a probability, and it's the same for estimating an average value of a certain thing. Okay. Any questions about this? No?